Hello.
Good evening.
Good evening, and thank you to you as well for staying late. We are both in Germany. I know it's like
Yeah,
6:20, so thank you very much. So Dr. Ernst is with been there ITZ, and he'll be telling us about opportunities and challenges of printed force sensors on 3D substrates. So
exactly.
whenever you're ready, please do share your slides.
Screen share. Yeah, okay. So I want to talk about opportunities and challenges of print force sensors on 3D substrates. I want to start with a short motivation why this is an interesting topic for the Franz Winder GmbH and for our main business field, in different connection applications. We're doing this with printing solutions. I will talk about shortly the specifications and limitations for this printing method. And then I will give you an overview for two specific kind of sensors for this force sensing resistor, FSR, and strain gauge, which we want to apply. So what is the motivation? We start with a classical connector. Yeah, a lot of mechanics, some electrical components, but as time goes on, also these connectivity solutions have to become more intelligent, and there is a need to apply different sensors. So with our technique, we can do temperature sensors, force sensors, heating application, and some other interesting topics. But the current field of application, we're thinking about some force sensors, to do some testing in the field of predictive maintenance, mating cycle. So we want to add some new functionality to a classical connectivity solution. And this is where we come in the whole picture. We are the Innovation and Technology Center. We are part of the Franz Winder GmbH. We have about 2,000 employees, and we are the Research and Development Department for printed electronics. We have an interdisciplinary team for physicists, chemistry, machine building guys, so that we can have different views on interesting topics. So, and one thing is we are specialized for this pad printing process. So the main goal is to print directly on 3D and structured surfaces. In order to do or achieve this goal, we have to focus on the printing process. So most printing paste or the commercially available printing pastes are for screen printing. So we have to adjust these printing pastes a little bit. This is where our chemistry is responsible for. We have to do our own analytics. So because it's a very niche printing technique, and we have to combine it with our electronics. So classical electronics layout, electronic development is a big part of our new sensors. With this pad printing technique, what we can do or what we are doing is we transfer from a printing form the printing paste directly on our 3D surface. What a 3D or structured surface can look like is when you see the picture on the bottom right side. This is a very inhomogeneous surface. But as you can see, the printing process works fine. We are able to print 160 millimeters square, and we are working with layers between 2 and 100 microns. And so this is the finest structures we can print with this technique are about 80 microns. When it works, I have a short clip how this production process looks like. This is our cellular connectors, and here you can see how much time it takes to print